Okay, so we want to draw the curve that is parameterized by this function. Okay. There's different ways that you can go about doing this. Here's what I'd like to do, and that is to let's compare this to this other function, p of t, which is sine t, cosine t. Now that's a different function, right? Parameterizing a different curve. What you notice is that, well, yeah, but still, I mean, that x and that x. The only difference is that there's a factor of 2, right? And then likewise, that z and this z, the only difference is that factor of 3. So if I can understand what this thing looks like, then all I have to do is stretch it by a factor of 2 in the x direction and stretch it by a factor of 3 in the z direction, and that'll tell me what this x curve looks like. Is that cool? Mm-hmm. Yeah. Okay. All right, so let's go to understanding this now. All right. Well, good news. Oh, let me remind us what this means. That's x, and that's y, and that's z. Right. So x and z have a Pythagorean relation. So, so this point, as it moves around in space, if I were to look at its projection into the xz plane, in other words, if I were to sort of throw away the y coordinate, in this xz plane, looking just at the x and z coordinates, it's going around in a circle. Right? And let's see now, z is the one is cosine, so when t is equal to 0, z is equal to 1, and x is equal to 0, so I'm there. And then as t increases, x increases, and z slowly starts to decrease, and not hard to persuade yourself into doing that. You don't look happy.
Oh, no, I'm just processing.
Okay, yeah, okay, all right, that's fine, yeah. Everybody good so far?
Yeah.
Now, that's not to say that this is what P is doing. P is, of course, doing other things. I mean, P is over here. P has a y coordinate, for example. And we've completely ignored this y coordinate. Bad color choice. This y coordinate here. Right? It's because we've ignored the y coordinate that we get a nice, pretty result that it's a circle. So now let's think about the y-coordinate. Well, this is not unlike a problem we did in class, right? I mean, the y-coordinate is just t, so it's just increasing at a constant, rate of 1. So what we have then is a point. We're looking at these blue points.
Oh, is this going to be the spiral one?
Yep.
I see.
Yeah. So we're looking. Oh, sorry. We're looking at blue points, whose sort of sideways shadow into the xz plane is going around in that circle. Like that, and then the red y-coordinate is just increasing at a constant rate like that. And if you kind of put it all together, that gives you that spiral. Does that make sense to everybody?
And how would you like to do the stretching?
Yeah. Well, yeah. I mean, this is another one of these situations where accept mediocrity as the goal, right? I mean, you're not going to get a really perfect, amazing. Wow, that's such a beautiful picture, right? And in fact, you don't even have to have everything that you're trying to communicate all in the same, all determinable strictly from what you've drawn. So you could say, for example, that I'm going to take this curve here, and we're going to stretch by 2 in the x direction. Is that what it is? Yeah, by 2 in the x direction, and then we're going to stretch by 3 Z direction. And then just take a whack at drawing the result. And, again, you're not going to make a great picture. But use a different color. I'll use green. So instead of starting there, it's going to start up here at 3. And it's going to, instead of going out to 1, it's going to go out to 2. Something like that.
But at like the first point with the blue spiral,
Yeah.
can we just like draw that and then say, just right on the side, like it's stretched by factor?
Yeah, I would encourage you to actually take a whack at actually drawing the result, just so that, you got to keep in mind the grader's point of view. I mean, the grader, it's not a question of what the grader thinks is sufficient communication of what, right? There's also the question of what will the grader notice, right? And if there is if the grader sees a picture and the picture is a picture of something that is not the curve that he's looking for, he's going to say, you did not draw the curve. Right? And then he might just not notice the little additional text. There's also the question of what the grader thinks is really important, and
like if we were just like label the original one, just like
I think it'd be good form to. I mean, the problem says draw a picture of this curve, so draw a picture of this curve. But again, don't hold yourself to this real high standard. This is fine. I think this would be full credit.
Okay.
If I were grading, this would be full credit.
Okay.
And it's not like it's artistically wonderful. Right? I mean, you can't. In other words, if I were to look only at this picture and ask, "What curve is that?" I don't know. It's kind of a loopy spiral, but I mean, there's a lot of information I can't tell. But this is good enough for this purpose. Okay, is everybody good on this problem?
Yeah.
Okay, let's stop that recording here.